So solving two-step equations. All the ones we did yesterday were one-step equations. Today it's going to take 2 steps to solve them. To undo two-step equations, use multiple inverse operations working backwards through the order of operations. So normally, order of operations, you do multiplication and division before you do addition and subtraction. When you are solving, you do it in the opposite way. You take care of addition and subtraction before you take care of multiplication and division. It works the opposite. Okay, that's what you're spending basically everything doing in solving equations is doing the opposite. Everybody's watching the video. Dead air, dead air, dead air, dead air, dead air. Okay, so when I'm looking at this equation, 2x plus 3 equals 15. Order of operations, you do multiplication before you do addition. But when you're solving, you do it in the reverse order. So the first thing I'm doing to the x is I'm multiplying by 2. Second thing I do to it is I add 3. To solve it, I do that backwards. I get rid of the plus 3 first. So my first step is to subtract 3 from both sides. And my first step is to subtract 3 from both sides. The 2x does not change because I can only take care of do anything to the 2x if I'm multiplying or dividing. It's just the 3 I'm getting rid of. So the plus 3 and the minus 3, these two cancel each other out. And I get equals 15 minus 3 is 12. Step 1, get rid of the addition or subtraction. Step 2, get rid of the multiplication or division. Here I have 2x equals 12. That's 2 times x. Opposite of multiplication is dividing. My 2's cancel. I get x equals 12 divided by 2 is 6. X equals 6. Okay. Really is not that much more than that. When you're doing a two-step equation, 90% of the time, this is what you do. Addition, subtraction, and then your multiplication and division. So what's my first thing I'm going to do on this one? What am I going to do first? I'm going to add 3 to both sides. So I have z divided by 2 is equal to 8. Right? 5 plus 3, yeah, 8. Now what? Z divided by 2, opposite that is multiplication. Multiply both sides by 2. Times 2, times 2, those cancel. I get z equals 16. You'll notice on my z I have a little mark across it. Okay, then go.
Do you want me to swap this Mayfield right now?
Yeah, I might as well.
Do you want me to take it on?
Yeah, I might as well. I mean, it's just fun.
Okay.
And I just want to get them in the right place. That's what we want to do. I know. All right. So notice with my z's, I put a little line across the middle so it doesn't look like a 2. Okay, when I handwrite them, you got to be careful about that. Typewritten ones, it's not a big deal. Handwritten ones, you got to be careful about that. I do the same thing if I have an S. If I have an S for a variable, I'll put a little line through the middle of that so it doesn't look like a 5. Okay, there are a few variables that are not good to use. O is a crappy variable to use. I should say capital L or lowercase l is a crappy one to use. I is a crappy one to use, or capital I, and S and Z. Those all look like numbers. You don't want to use that, right? Almost never use O for anything, for any kind of a variable. S and Z do pop up. Okay. Questions? It's not too hard. You handle what we did yesterday. This is just one extra step per problem. Okay. Show your work. Do the work just like I have here. Okay. Okay, turn the page over. Now, there is more than one way to figure this out. I will show you what I want to see, because you need to be able to do equations and write equations from information from a model. I have to figure out what is an equation to go with this. Write the equation and solve the equation. Okay? Excuse me. You're making a bulletin board to advertise community service opportunities. You plan to use half sheet of paper for each ad. So you're using, for each advertisement, I had a bunch of, here we go. You're using a half sheet of paper. Okay. For each, you'll also need 5 full-size sheets of paper for the bulletin across the top. If you have 12 sheets of paper total, how many ads can you create? Now, with particularly the diagram given up there for modeling the 12 sheets of paper, it's actually not that hard. But let's take a look at how I would do this as a mathematical model. So I either use half sheets or full sheets. The number of full sheets of paper is always the same no matter how many things I put on the bulletin board. How many sheets of paper, full-size sheets of paper, do I use every single time? What does it say? How many full-size sheets of paper do I need? Every single time I use 5. That never changes. That is a constant. So that would be my plus 5. That's my constant value by itself. The number of half sheets depends upon how many flyers I put on the bulletin board. If I only have 2 people who want to put something on the bulletin board, I only put up 2 half sheets. If I have 5 people want to put something up there, I put up 5 half sheets. This varies. The number of half sheets varies depending upon how many people want to post on the bulletin board. So this is the variable portion of my equation. So I have 5 sheets every single time, but I have to have a half sheet of paper for everyone that does it. So if one person wants to post something on the bulletin board, I need 5.5 sheets of paper. If 2 people, I need 5 and 2 times 1/2, or 6 sheets of paper. This depends upon the number of half sheets, depends upon how many people want to post on the bulletin board. The question is, if I have 12, if this is equal to 12, how many people can advertise? How many notes can I put up on the bulletin board? That's my equation. Half sheet per person. That amount changes depending upon how many people want to put on there. 5 sheets are used no matter what. If I have 12 sheets of paper, how many people can post on my bulletin board? Solve my equation. Subtract 5. And I get 1/2 x equals 12 minus 5 is what? 7. Thank you. And because I don't have enough room to keep working down, yes. I'm getting there. So I have 1/2 is equal to 7. Sorry, 1/2 x is equal to 7. I want to get x by itself. I need to get rid of the 1/2. What times 1/2 gives me 1? 1/2 times 1/2 is 1/4. 2. Multiply by 2. So multiply both sides by 2, and I get x is equal to 14. Now, this is the algebraic way of solving a problem. Is the algebraic way the only way? No. Here's a way to do it. 12 pieces of paper. I use 5 right off the bat. How many pieces of paper do I have left that I have not used? I've got 7. 1, 2, 3, 4, 5, 6, 7. How many do I get per those? I get 2. 2 times 7 is 14. It's another way of solving the same problem, but just not using algebra. Are you using math when you do that? Yes, you are. But still using math. And not because you're multiplying 2 times 7. Mathematics is more than just numbers and letters and variables. Mathematics is solving problems, coming up with solutions, figuring out how to do things. There's a lot more to math than just people, oh, I'm really good at math because I can add, subtract, and multiply and divide really well. That's just a very small part of mathematics. Okay? Doing algebra, sticking variables in and solving these equations, that's just a very small part of mathematics. Okay? Mathematical thinking is solving this problem using several different ways. That is mathematical thinking. And that's one of the things to learn how to do in here. Okay? Now, there is one more example problem, and this is an important one because this one's slightly different than the problems on the previous page. On the previous page, I had 2x plus or minus something. I don't remember exactly what it was. And I had z divided by 2 plus or minus something. And what did I do first? I got rid of the addition or subtraction. These types of problems are different. Okay, solving with 2 terms in the numerator. Here I have, you can think about it this way, I have x minus 7 in parentheses because I have to do what's on top before I can divide by the 3 on the bottom. So it's just like having x minus 7 in parentheses. I don't, but it's the same thing. Now, I said earlier, when you're solving a problem, you use reverse order of operations, right? That's why we did addition and subtraction before we did multiplication and division. If I have parentheses, that's the first thing I do when I work, but when I solve, it's the last thing I do. So normally, I would add 7 to both sides, but because I have this in parentheses, even though technically they're not written down there, they are there. The first thing I actually need to do is get rid of the 3 that I'm dividing by. It's the one time you don't get rid of the addition and subtraction first is if you have a bunch of stuff divided. Your first step is actually to multiply both sides by 3. That cancels. You get x minus 7 equals negative 36. Add 7 to both sides. X equals negative 29. Be careful when you're doing your work today. Okay, pay attention to how the problem was written. Usually, get rid of addition, subtraction, and then your multiplication, division. The ones that are like this, where you have a big fraction and you have more than one thing in the denominator, you got to get rid of the number on the bottom first, and then take care of your addition and subtraction. Okay? Any questions on this?